Any questions? Please feel free. If you have any question, yes. Hello, come online, come online. Any questions? Are you understanding the whole concept? Are you getting it or you are confused?
I don't have a question, but I'm appreciating what you're saying. Hello.
That's
Okay.
fine. Thank you.
Okay. But I hope you understand, right?
Yeah, I understand. And
Fantastic.
I think a while ago, I was also wondering the difference between both things.
Okay.
And it's just as I don't have a question, but like, I'm appreciating what you're saying. Hello. Yeah.
Mm-hmm.
But it makes sense that it's what is moving the electron.
Mm-hmm.
So yeah. Yeah, I understand. And
Fantastic.
I think a while ago, I was also wondering the difference
You have
between
no
both things.
idea.
Yeah.
And I'm
And it's just
definitely
as
going to
we are
leave this
saying,
particular
right?
video online,
And it makes
right?
sense, especially if you
And
call
see
it
comments.
electromotive force, because it
Okay.
makes sense that it's
If
what is
no
moving
further
the
questions,
electron.
then let's continue. But please,
So yeah,
just
that's
feel
what I
free
want
to
to
ask
say.
the questions if you have to. Is that okay? Lisa, are you okay?
Yeah, think I'm okay.
Your yeah doesn't really sound cheerful. Are you confused?
Oh, okay. Okay,
Okay.
I'm just wondering something.
Okay.
Is energy that causes the electrons to move, or is the movement of the electrons that causes the
Okay.
energy?
Good work.
And also,
Yeah, think I'm okay.
what actually lights up the lamp? Is it the movement of the electrons, or is
Oh,
it the
I'm okay.
energy that is
Okay, I'm just
flowing
wondering
around
something.
the copper
Is it
that lights the
energy
lamp?
that causes the
Okay.
electrons to move, or is the
Okay.
movement of the
So the
electrons
first
that
one,
causes
is
the
it the energy
energy?
that is moving the
And also, like
electrons, right?
um
Yes,
um
something like
um,
that.
what actually
Okay.
lights up the
So
lamp?
let me
Is
ask
it
you,
the
can you
movement of the
hold your
electrons,
belt
or it
and
is
pull
the
yourself up?
energy that is flowing around the
No.
You
copper
can't,
that
right?
lights the lamp?
So for you to be pulled up, something else has to do that. True or false?
Yeah.
Exactly.
True.
Okay. For work to be done, the
It,
force cannot
yes.
come from the object itself. Something else has to move the object.
No.
Is that okay?
No.
Yeah.
Electrons move in response to electric field.
True.
Okay? Electrons move in response to electric field. Now, let's take the batteries away for the time being. When we take the batteries away, the electrons still move all right, but then their
Yeah.
movement is described as haphazard. It's like they have been excited by thermal energy. Okay, if we are taking copper for example, they have been excited by thermal energy and they move anywhere randomly, right? And so far as the electrons are moving randomly, they don't contribute to current because there is no specific direction of movement. Is that okay? Now, the moment we connect the battery so that there is a potential gradient, it is like the electron is being dragged to move in the direction of the gradient. So let me ask you, can the electron drag itself?
No, it can't drag itself.
Exactly. That is also the reason we call it drift. They drift. Okay. If you say something move and something drift, there is a difference, right? If I say move, it means you yourself, you are doing the movement, right? But if I
No, it can't
pull,
drag
or
itself.
something like that, I don't know if you are getting the whole thing, right? If I pull you,
Yes, I'm getting it.
exactly. Me pulling you, yes, you end up moving, but it doesn't mean you wanted to move. Okay. The electron drifts when the energy, because of the field, and the field is associated with electric energy. Now, see, when the energy moves, remember we said
Yes, I'm getting
electrons get excited, right? Fantastic. For light to be produced, for simplicity, let us let us talk about incandescent bulbs, right? Now, incandescent bulbs, the way they produce light is by heating up, right, to a very high temperature, and then there are some gases, neon gases in the bulb that causes the fire to bright. Let me put it like that, right? You see, that energy that is required by the incandescent, the element to do that, that energy is never what is being carried by the electrons. Okay, that energy is moving through the spaces around the wires between the battery and the, what do we call it, the bulb, and it go, remember I said that electrons can also be excited through electric field. Okay, I think in the previous session I said we can excite electrons by thermal energy, by light as in solar panels, or by an applied electric field. And what does the battery produce? Electric field. So this electric field cause the materials, I mean the, if it is an incandescent bulb, the filament, incandescent bulbs are usually made up of tungsten, right? The atoms in the tungsten, or the what do you call it, electrons in the tungsten begin to excite, okay, and in so doing they keep falling off, releasing their energy to their atom, and the atom itself begin to excite, shake around, and then we have heat generation. This heat generation is what glows for us to see as light, and that temperature could be as high as like 3000 degrees Celsius. Okay, so basically that's what is happening. Okay, now let me actually even bring in this. Electrons don't move at the speed of light. Do you understand that? Do you know that? Oh, she's not here, right? So electrons don't move at the speed of light. The energy actually does travel at the speed of light, but then it depends on the material through which it is traveling though. Is that okay? And even if you take AC, right? AC at one point is going, the electrons at one point are going right, at another point they are going left. So basically AC, in an AC system, electrons don't actually move around like they even do in DC, right? So if the electrons don't move, they are just at one place changing direction. How does that electron travel to release its energy to your house? That's one question I need you to look at. Also, the electrons barely travel a few millimeters per second, right? So if the energy is if we are talking about energy movement in closer to the speed of light, how can an electron that is traveling at a speed of barely a few millimeters per second deliver such energy at a high speed? It's not possible. Okay, so please, these were things that we previously thought was happening, right? And so we now know that it is not. Unfortunately, the harm has already been caused. Okay, so yeah, Lisa, I think you missed some. I said some interesting stuff. You missed it, so you watched the Q&A session on this part, right? And you get it. Please, are you okay? Who has questions or maybe comment on what I've just said? Lisa, can you hear me? Hello, Lisa. I think her network. All right. Please, the rest of you here, any questions on what we are talking about? These things are very important. Any questions?
Okay, so I want to clarify
Mm-hmm.
on what makes the conductor to heat.
Exactly.
Right.
Exactly. You see, so
Okay.
so if let me ask this question. If
Okay,
the
so
electron
I want to
if the
clarify
electrons are the
on
ones delivering their
uh,
energy to the load,
what
how
makes
even does the
the
electron know that, hey, this is the
conductor
load, let me
to heat,
release my energy there?
right?
And why does the
Because,
conductor heat
okay,
up? Because if the electron is releasing its energy to the load, right, then there shouldn't be any transfer of energy within the conductor from the electrons. So the conductor doesn't have to heat up. The conductor heating up is as a result of the electrons losing their kinetic energy to the ionic cores within the conductor. Okay? So in metals like copper, they have what we call metallic bond. And the way metallic bond happens is this. Because we said that they require very little energy to excite their valence electrons into their conduction band. This thing happens at room temperature. So at room temperature, if you take a look inside copper, you realize that it's like they have an ionic core at the lattice points, okay, and the electrons are a lot of electrons, so we describe it as a sea of electrons are surrounding these ions, okay. So there is constant collision between the, should I even say collision, technically it won't collide, but anytime an electron falls back into an ion core, it has to release the energy, its kinetic energy. And all these kinetic energies are released in the form of heat. That's why if so much current flows through the conductor itself ends up heating. But if the idea is that the electron has to deliver its energy to the load, how does the electron know that this is the load, let me deliver my energy? Because if you take an incandescent light bulb, for instance, it is basically a tungsten wire. So it's like from copper to tungsten back to copper, right? So the electron does not have any means of knowing that, oh, I've moved from one material to another. It is just moving about. You get the point? So this whole thing of the electrons rather, no, that's not what is happening. That's never what's happening. The electron moves at a speed so slow that that's not even possible. The energy we are talking about is moving closer to the speed of light. Electrons are basically drifting around a few millimeters per second. Okay? And even if you don't agree, just consider alternating current, AC, right? AC is just a voltage that changes polarity. That means at one point it's pointing this way. And if the AC, the potential gradient is in this direction, that means electrons or current is going to move in that direction. Then it changes, right? And this change is happening 60 times per second. Okay. So basically, electrons in an AC circuit don't move anywhere. They just keep going back and forth at the same place, right? Now, if they are going back and forth at the same place, how then were they able to travel from, let's say, Akosombo Dam to your house to deliver the energy? Now, even along the way, the power goes through transformer substations. There are physical gaps between the transformers, okay, so that the energy has to translate in the form of what do we call it? Induction, through induction. Yes, or field. So how then does the electron move from that source at this slow speed to your house to power it? Okay, so that is not what is happening. There is movement of energy, and this energy propagates in spaces along the wires. So the wires just serve as some form of a waveguide, okay, something directing where the energy should pass. And in response, electrons move through the wires. So the way we get to see that energy is actually flowing is by the fact that the electrons move. Okay, and once the electrons are moving, they will keep releasing their energy to their atom cores, the ion cores in the conductors, and these conductors will have to radiate them out as heat. So eventually you get your conductors also heating. Please, is it okay?
Yeah, that's good.
Oh, who have I made confused? I wish we were in a physical room so that I can use illustrations. Yeah. So Lisa, are you good at this point?
Yeah, that's good.
Yes, I think I am.
Okay. I don't want you to think. I want you to be. Jifa, how about you? Jifa, are you good? Are you here?
I'm still trying to understand.
Hmm. Okay. But do you have any questions? Do you have any Remember, I said these
Yes, I think I
sessions are
am.
for you guys, right? Even if we have to spend all the time for me to get you to understand, that's exactly what I'm going to do. Okay, there's no point rushing out when you don't get
I'm
what
still
is being
trying
taught.
to
Okay, because
understand.
everything builds on the previous. Okay, yeah. So if you have any questions, please, I'm ready to explain to you. Don't worry, I understand that it takes some time to get your mind wrapped around. I've been actually thinking through this for about 2 years. So it's not that simple. Okay, all right. So I guess we could end the question time here and continue. Okay, so there will be another time for questions. So if you come up with anything, just write it down. I'll answer it for you. Okay, all right.